So hello friends, welcome to George and Whitney tutorial. So in this video we are going to look at the laws of thermodynamics. So basically in thermodynamics we have basically four laws. We have the zeroth law, the first law, second law, and third law. So we are going to begin with the zeroth law. Now under the zeroth law, now we are going to consider three bodies, that is body A, B, and C. Now if we independently bring A in contact with the C, so equilibrium is going to be reached when A and C are in what? Thermal equilibrium. Then also B, bring it independently in contact with the C. Equilibrium is going to be reached when B and C are in thermal equilibrium. Therefore, if A is in thermal equilibrium with C and B is in thermal equilibrium with C, that means A is also in thermal equilibrium with what? With B. You seen that? So basically this is what we call zeroth law of thermodynamics. Therefore it can be said that if two bodies are individually or independently in a thermal equilibrium with the third body, if two bodies are individually in thermal equilibrium with the third body, then the two bodies are also in thermal equilibrium with each other. Basically that is the zeroth law of what? Of thermodynamics. It is this guy looking at three bodies in what? In thermal equilibrium. Now that law enables us to compare temperature of two different bodies. So it enables us to compare temperature of two different bodies. Now for example, since I can know that A is in equilibrium with C and also B is in equilibrium with C, then I can determine the temperature of B without bringing it in contact with the A. So basically that is the what? The zeroth law of thermodynamics. Now so the next law is the first law of thermodynamics. But before reaching the first law, we are going to let's first look at what we call thermal equilibrium. In fact, it is thermodynamic equilibrium. Now, when we talk about thermodynamic equilibrium, thermodynamic equilibrium is basically looking at equilibrium of a system. So a system, so if we talk about thermodynamic equilibrium, a system is said to be in thermodynamic equilibrium if it is in thermal equilibrium. So in some video I talked about, my previous video I talked about thermal equilibrium. We said thermal equilibrium is when the rate of heat transfer to and from the system is the what? Is the same. Then the system is said to be in thermoequilibrium. So we are saying that a system is said to be in thermodynamic equilibrium if it is in thermoequilibrium chemical equilibrium and mechanical equilibrium. So these are the three states. So for you when you're defining thermodynamic equilibrium, so you must say that a system is said to be in thermodynamic equilibrium if it is in a thermal equilibrium where the rate of heat transfer to and from the system is the same. Then chemical equilibrium, you're looking at the particles in motion, their kinetic energy, the microscopic part, kinetic energy, potential. Then in mechanical and also mechanical equilibrium. So mechanical equilibrium, you are looking at the forces acting on the system, so they must be balanced. So that is what we are saying. The system is said to be in thermodynamic equilibrium if it is in thermal equilibrium, chemical and mechanical, within itself and the surrounding. So inside the system, within the system, inside it must be in thermal, chemical and mechanical, and its surrounding must also be in a thermal, chemical and mechanical. So if you happen to find a system that is in, let me say, thermal and chemical, and it is not in mechanical, that system is not in thermodynamic equilibrium. So for it to be in thermodynamic equilibrium, it must be in thermal, chemical and what? And mechanical. So therefore we can look at the first law. The first law of thermodynamics. Now the first law is basically the law of conservation of energy. It is basically the law of conservation of energy. You see that? Now you know the law of conservation of energy. So the law of conservation of energy states that energy can neither be created nor destroyed, but can be transformed from one form to another. So this first law of thermodynamics can be stated in two different ways. So we are going to look at the second way. Now, basically, to understand this law very well, for example, if we have one body, let me say this system, we have this system A, and we have a system B. So we are saying that this system, let me say, it is going to lose heat. So it is going to lose, let me say, 100 joules of energy. So it is losing, that means it is losing, so give it a negative as it is losing, give it a negative as it is losing energy. So as it is losing, where do you think this energy will go? So this energy will be absorbed now by the what? By the second body. You get that? So for it, the system A, its energy is going to decrease because it has lost some 100. So its energy is going to decrease by 100. Then that energy that has decreased by 100 is going to be gained by B. So this one is going to gain plus 100 joules. So this one gaining the 100 joules, this one, its energy is going to increase by 100 joules. Therefore, energy is neither created nor destroyed, but it is transformed from one form to another. So this energy. So this is basically what we mean by the first law of conservation of energy. So which is the first law of thermodynamics. And another way you can state it is that the first law of of thermodynamics, the heat, the quantity of heat supplied to a system. Now, for example, we have this system. Now, when you supply heat, so this is the heat supplied. When you supply heat to this system, now the heat you supply to this system is going to be absorbed by the system. Now, for example, you can apply it to this, then the system can move. So the heat you supply, which is Q, is going to be equal to, now when you supply this, the temperature of the system must increase. Therefore, when the temperature increases, it is going to increase its internal energy. Therefore, the heat you supply will be changing in internal energy of that system, and also doing work to the system. So therefore, the heat you supply, which is the Q, change in heat supplied, is equal to the change in internal energy. Internal energy is divided by U. So therefore, the change in U plus the work done. So you can say change in work done. So basically, this is the first law. This is an expression of the first law of what? Of thermodynamics. So this one is the expression for the first, where the Q is the heat, quantity of heat supplied, then the U is the change in internal energy, then the W is the work done. So basically, this is it. So now under this, we can look at what we call the sign convention. Sign convention in thermodynamics. Now basically, this is a crucial part that you take into consideration. It is a crucial part. Sign convention. Now, sign convention, basically look at the sign used. Now, when we are looking at this, we have two parts. We have the surrounding, we have the system. Now, having the system, we also have the what? The surrounding. Now, we have the system and surrounding. Now, under thermodynamics, when we are taking consideration, our point of view is the system. You get that? So therefore, we shall be like standing at the system, then looking at the surrounding. Not standing at the surrounding, looking at the system. So we shall stand at the system and observing its properties. Now, if for example, if the surrounding does work on the system, so we have work done on system. If work is done on a system, then that work is said to be negative. Give it a negative sign, meaning that work is done on the system. You get? Now, if work is done by the system, so we give it a what? A positive. So since the system is doing work, so we give it a positive. You get that? So now the opposite will be true if we are considering the surrounding. Work done by the surrounding. If the surrounding is doing work, it is doing. Now we are considering if we are standing on the surrounding and we're observing the surrounding. If work is done on the surrounding, it will be negative. So now work done on the system will be negative, but it will be the surrounding doing work on the what? On the system. Therefore, the work done by the surrounding will be positive. You get that? So here for the surrounding it will be positive. Then here for the surrounding it will be negative. So that is the basically sign convention in thermodynamics. So thanks for watching. Don't forget to subscribe and hit the bell bar for more notifications. Thank you.